Hi everyone, in today's lesson I'm going to show you another method of how to solve systems of equations in three variables. The row echelon form of a system of three variables follows the stair-step pattern with leading coefficients of 1. So this here is the system of equations that you're used to seeing. This is a system of equations in what we call row echelon form. And with row echelon form, all the leading coefficients, so the x has a coefficient of 1, the y has a coefficient of 1, and so does the z. And all of the other variables are eliminated. There's no x here, there's no x and y here. Now, solving a system of linear equation that is in row echelon form using back substitution method is much easier to solve than leaving the system in its original form. So what do I mean by back substitution? Let's take a look at this system of equations that you have here. From this third equation, so let's go ahead and label this as equation 1, this is equation 2, and equation 3. So from the third equation, we can conclude very easily that z is equal to 2. So let's go ahead and write that. And next, what we would do to find the y value is that we would take this z value of 2, plug it in here, and then we would get y. So we can substitute our z value of 2 into the second equation, and we can solve for y. So let's take the second equation and plug in z. Positive 2. So y plus 8 equals 7. And then we could subtract 8 on both sides. And y is equal to negative 1. Now, finally, our last step, if we wanted to find the x variable, we will plug in the y and the z to find our x. So we're going to substitute the y equals negative 1 and the z equaling 2 to solve for our x value. So go ahead and do that. We have x minus 2y plus 3z equals 9. X minus 2 times y plus 3 times z so we've got x plus 2 plus 6 equals 9. X plus 8 equals 9 minus 8 on both sides. And then we get that x is equal to 1. And that's our final answer. Okay, let's move on to the next page. Next, I'd like to show you a new method of solving systems of equation called the Gaussian Elimination method. Okay, so two systems are said to be equivalent if they have the same solution. So to solve a system of equations that is not in row echelon form, we can use any of the elementary row operations below to write an equivalent system that we can solve using back elimination. This process is called the Gaussian Elimination method. So there are elementary row operations, which are you can interchange two rows, you can multiply one of the equations by a non-zero constant. You can add a multiple of one of the equations to another equation to replace that second equation. So the whole point of all of this is normally I would give you a system of equations that looks like this. And I would say solve for x, y, and z. And you'd go through a whole big process of eliminating x's in both variables and both equations, and then eliminating y's and then finding the z or what have you. But our plan is really to eliminate this into the row echelon form, where there's a 1 in front of the x, a 1 in front of the y, a 1 in front of the z, so 1, 1, 1 on the diagonal, and eliminate the x here, eliminate the x, and eliminate the y here, and have it all equal to numbers. So I'm going to walk you through the steps of using these elementary row operations until you can get used to it yourself. So since we already have our x being 1 here, just like we want here, we're going to leave the first equation alone and we're not going to touch it. So I'm going to go ahead and write the first equation. again because we don't need to change it. And I'm going to rewrite the third equation because I'm not going to do anything with the third equation. Now, what I want to do first is try to eliminate this x value right here, because then that eliminates my 0, right? Then I have nothing here. So what I'm going to try to do is add the first equation to the second equation to create a new equation, a new second. So if I do that, I add the first to the second. I'm going to do that over here. I have x minus 2y plus 3z equals 9. I'm going to add the first to the second. So if I add these, I get y plus 4z equals 7. So I'm getting close. I've now eliminated this x here. So now I need to eliminate this x here. So to do that, I want to see what I could do. Well, I'm still going to leave the first equation alone, but what happens if I add -2 times the first equation? So if I put a -2 here, I could then add it to this equation, and then these would cancel. So again, I'm going to add, first I'm going to rewrite the first equation because I don't want to change that. I want to rewrite the second equation because I don't want to change that. And now I'm going to do what I suggested. I'm going to take -2 times the first equation So let's do that first. So -2x plus 4y minus 6z equals 18. And I'm going to add this to the third equation. So when I add them, I get -y minus z equals, so this should be a negative, -1. So now I'm getting closer. I've eliminated the x's here. I've eliminated now the x here and here. Now the last thing I need to do is eliminate this y value. So I'm going to add the second equation to the third equation to create a new third. So I'm going to put a negative there. Sorry, I forgot it. So again, I'm going to add the second equation to the third equation to get a new third equation. So I'm going to leave the first equation as is, and I'm not going to touch anything. I'm going to leave the second equation as is. I'm not going to touch anything. And now I'd like to add the second equation, so y plus 4z equals 7, to the third equation. These will cancel. This will be 3z equals 6. And that is my new third equation. And now I'm almost there. The next thing I need to do is get z by itself. So I need to get rid of this 3. So one of the rules in the row operations is that I can multiply any row by any non-zero constant. So I'm going to multiply the third equation by 1/3 to create a new third equation so I can get rid of this 3. So again, I'm going to leave the first as is, leave the second, and I'm going to take this 3z equals 6, which is my third equation, and multiply it by 1/3. So 1/3 times 3 is z, and 1/3 times 6 is 2. So then I get z equals 2. And now it says, now that I've created my equation in row echelon form, where I have zeros and zeros, I can now use back substitution to solve. So I have z equals 2, that's definite, and this problem is exactly the problem on the front page. So you're just going to use back substitution, just like we did. Plug in z is equal to 2 into here. Oh, I think I copied this wrong. I apologize. I just noticed that this should be a 7. Okay, so then 7, 8, so y is equal to -1, and then x minus 2y plus 3z equals 9. We plug in y is equal to -1, z is equal to 2, so x plus 2 plus 6 equals 9, and this would be x is equal to +1. Okay, so same as before, but now we're introducing things called elementary row operations. Now I know they're difficult to see, so you're going to have to get used to this. So what I'd actually like you to do now is kind of absorb everything that I just did. Read over these bold statements. This is how I'm using these row operations to manipulate stuff. And we're definitely going to practice this over the course of the next few days, so don't stress if you're having some difficulty with it. And come in with questions tomorrow. All right, have a good night.